8.2 is overextending trig functions to any angle, which, like everything else up until this point, is not new, just merely an extension of ideas we've already covered. So we're going to be using our two trig function waves here, our cosine and our sine wave, and then we're going to be looking at the unit circle as two of our tools to help us think about these relationships of trig functions all the way around to 360 and for infinite loops around, or all the way out to 360 and infinitely to the right or to the left from 0. So we're going to look at a couple examples of what we're going to be doing in this section. Here I have something that is the sine of some angle is 5/13, and we know that that angle lies between 90 and 180. So we're looking at this section right here. This could also be written as pi/2 to pi, and then our answers would need to be in radian form. So let's go ahead and make a little sketch. We're going to be looking at an angle here. I like to kind of make it my angle or my triangle be in whatever quadrant it would live in, and so 5 and then 13. And then I'm going to take 13/169 minus 25. Get our last side squared, 144, so it's 12 equals b. And then given this information, 12 being here, it should technically be -12. That's why they've given us this information here. So cosine is going to be -12/13. Secant is going to be the reciprocal of that. Tangent will be opposite over adjacent. 5/12, also negative. And I'm going to go ahead, and use my calculator to do an inverse theta function because I do not know, I'm sorry, this value is not on the unit circle. So I can get my calculator to behave. There we go. Inverse sine of 5/13. And I know that I'm in degrees because I set it to be that way. And theta looks like it's about 22.12. I'm sorry, 612. 6.2. Sorry, there we go. Okay, the next thing we're going to look at is we're going to relate these larger angles back to angles that were previous. So if I was going to look at sine of 135, which I put a little tick mark here for 135, I can say that this angle right here is going to be the same, have the same ratio as this angle here. So it's going to be the sine of 180 minus 135. So whenever I'm talking about sine, I'm going to be 180 degrees minus the theta I'm interested in. So the sine of 45 is √2/2. So those two things will be equal. Okay, cosine of 300, that's about here-ish. And I know that cosine is representative of x, so x is not the same this way, x is the same this way. So these two values here and here are going to be the same. So I'm going to use an identity saying that 360 minus theta, when referring to cosine, gives us our value that we're interested. Now, knowing the unit circle here and feeling really comfortable with it and knowing all of the relationships in it is going to really help you be able to move through these types of questions more quickly. So right here, cosine is 1/2. That's the same as the cosine of 60, which came from 360 minus 300. Okay. couple little formulas that come up out of this section. The area of triangles formula comes out of this. So the area of a triangle, the way we've done it in the past, of course, was 1/2 base times height, where we knew that the base was the side intersecting the height. But in this case, we can do this on any triangle, like a general triangle, by taking 1/2 A, B, and then the sine of the angle included between them. Now in this case we're saying A, B, and C. Sometimes kids get confused and I think it always has to be the side that's across from the big A. But these are just placeholders. Remember, it's two sides and their included angle. So here's an example, 13, 150, and 8. Now this may have been labeled as like side C and side B and angle A, but these are just placeholders, so that would be fine. Two sides, included angle. So I'm going to say the area of this triangle is 1/2 13 times 8 times the sine of 150. And I'm just going to use my calculator to do that. 0.5 times 13 times 8 times the sine of 150 is 26. Okay. This question's asking a slightly different type of scenario, type of setup, where they've given us the area of the triangle and then provided us some information about them. So I have A, B, and C, where C is the included angle. So I have a triangle A, B, C, something like that. Now my picture probably isn't very good, but that's all right. B, little b here is the side opposite big B. 8 is going to be the side opposite big A, and C is the one that's between those two, given this diagram. So there's our question. So 35 from the area equals 1/2 8 times 13 times sine of theta. So we're going to take our handy dandy calculator and go 35 divided by the quantity 0.5 times 8 times 13, and I got 0.673077. So I'm just going to hold that value in my calculator. And going to go ahead and take a trig function, and I want to know what the theta is, so I'll do inverse there. And I clicked up and I grabbed that. I'm going to hit enter there. Now I'm going to actually take the sine of the value that was calculated. I could have also done the sine inverse of this whole quantity in there, but since this already calculated it for me and this is as exact as we're going to get, that's fine too. I'm just going to hit enter. And in degrees, my theta is 42.305. There's one other formula that is in this section. So we have the area of a sector, which is 1/2 r squared theta, where theta is in radians. That's one formula. The area of a triangle, that's in this section, 1/2 AB sine C. And then we have these two different rules here. So the sine of theta can be written as the sine of 180 minus theta, and the cosine of theta can be written as the cosine of 360 minus theta. So those are some of the rules that came out of this section. These two are in your formula sheet, so be sure that they'll probably show up pretty frequently. These two You can memorize them, or you can always relate back to your unit circle. So do feel comfortable with your unit circle. It's going to be one of the most powerful tools that you have. All right, let's move on.